Welcome to the AI for Career Success video overview by Curt Robbins. We're experts at AI coaching and helping professionals like you and your employees upskill in AI. Today, we're going to dive into what could be a really significant new era for computing infrastructure. Our overview is based on a TechCrunch article from March 20th, 2026, written by Tim Fernholz. The piece outlines a truly ambitious new frontier for how we process data. And the core idea, the whole thesis, really, is captured perfectly in this quote from Blue Origin's official filing with the FCC. The goal is pretty straightforward: to relieve the growing strain on Earth's resources by moving the most demanding computational tasks off our planet. So here's how we'll break it down. We'll start with Project Sunrise itself, then explore why we're even thinking about moving computing beyond the atmosphere. After that, we'll look at the new space data race, cover the very real challenges, and finally discuss the vision for computing in the 2030s. Okay, so let's start with the catalyst for Tim Fernholz's report, Project Sunrise. This is Blue Origin's official proposal to the FCC, and it signals their very serious entry into the space-based data center arena. The scale of this project is just immense. Blue Origin has requested permission for a network of over 50,000 satellites. And let's be crystal clear here. This isn't about consumer internet. This is a dedicated orbital data center. The architecture that's described in the filing is actually a two-tiered system. You have the main Project Sunrise constellation, which handles the computation itself. And then you have a totally separate network of satellites called TerraWave, and its job is to act as the high-speed communications backbone, shuttling data to and from orbit. So, this begs a really important question. What is the fundamental driver behind a project this monumental? Well, the answer lies in the ever-growing demands of modern computing, and, frankly, the limits of our infrastructure here on Earth. Tim Fernholz's article highlights several key advantages. First, in orbit, solar energy is abundant and, for all practical purposes, free. There are also fewer regulations to navigate. This move also directly eases the incredible pressure on Earth's energy grids and water supplies, which are heavily taxed by our current data centers. And maybe most critically, it allows companies to outsource their most resource-intensive AI work. And to be precise, the main workload we're talking about for these orbital data centers is AI inference. As you can see, this is the operational phase of an AI model, where it's constantly processing new data to make predictions. It's a non-stop, high-volume task that consumes a massive amount of power, making it the perfect candidate to move off-planet. But here's the thing. Blue Origin is not alone in this endeavor, not by a long shot. Their filing is just one part of a larger and rapidly escalating competition to build the next generation of cloud infrastructure in space. And as this table illustrates, the ambitions here are just staggering. I mean, SpaceX has filed for a network of 1 million satellites for a distributed data center. You have the startup StarCloud proposing 60,000, and even Google is in the game with its Project Suncatcher concept, planning a 2-spacecraft demo for next year. The dynamic between the two giants, SpaceX and Blue Origin, is particularly interesting. As Fernholz notes, many are betting on SpaceX's Starship to dramatically lower launch costs for the entire industry. But Blue Origin might have its own strategic advantage with its operational New Glenn rocket, potentially allowing for the same kind of vertical integration that made SpaceX's Starlink so dominant. Now, despite all the excitement, it is absolutely crucial to acknowledge the profound challenges that must be overcome before this vision becomes reality. And we're not talking about minor technical issues here. The hurdles are really multifaceted. On the technology side, you've got to figure out how to cool things in a vacuum where heat doesn't dissipate easily, perfect high-speed laser communications, and harden advanced chips against space radiation that can corrupt data. Economically, the sheer cost of launching all that hardware is still a primary barrier. Environmentally, adding this many new satellites raises serious concerns about orbital congestion and collision risk. And finally, there's the atmospheric impact of burning up thousands of old satellites, which could pose a real threat to the ozone layer. This all raises a critical question, doesn't it? Can these monumental technological, economic, and environmental problems actually be solved? Okay, so let's conclude by looking at the projected timeline and what the future implications could be for IT and cloud computing as a whole. The path forward is definitely a long one. We're seeing the initial regulatory filings right now. In 2026, small-scale demonstrations like Google's are planned for the near future. But The experts that Fernhold cites believe that large-scale operational projects, the kind proposed by Blue Origin and SpaceX, are unlikely to really materialize until sometime in the 2030s. And this brings us to the core takeaway for any professional in this field. This isn't just a science fiction concept. It's being proposed as a long-term solution to a very real problem: the finite energy and water resources we have on Earth to power the exponential growth of AI. And that leaves us with a provocative final thought. As the demand for computation continues its relentless climb and our terrestrial resources become ever more strained, we have to ask, is the migration of large-scale AI infrastructure into orbit not just a possibility but an inevitability?
Thank you for watching. This is where we teach you AI and help you get smarter than your competition.
If you like these videos, use the QR code at the beginning of this video to buy us a coffee or hire us to coach you or your employees in AI. Please subscribe to the AI for Career Success YouTube channel. We also ask that you like, comment, and share to help us reach a wider audience.